So hello, my name is Brian Terlson. I work in Azure's developer division. I spend time building libraries for Azure, and I'm also writing a programming language called Cadl that I'm here to talk about today. You can follow me on Twitter if you like. I'll probably be tweeting a lot more about Cadl in the coming weeks. Quick disclaimer. Cadl is under construction. Not even the name is final. We're working on a new name. And so, as you're watching this presentation and as you go out to the website and you see what Cadl is doing, please give us feedback. That's why we're here. We're here to get feedback. We're very interested in hearing how you want to use Cadl, what you would like to see in the language. And we'll take that to heart, and that will inform our plans as we move towards stabilizing. So, keep that in mind. This is an early look, and please give feedback. Fundamentally, Cadl is a high-level dynamic programming language that is for defining APIs. That's an intentionally general description, and we'll get to why that is in a bit. But first, I want to talk about why we invested all this time building this language. Azure spends a significant amount of effort building services, believe it or not. And we have a very huge corpus of OpenAPI. You can see some of that OpenAPI on GitHub if you go to our Azure Specs repo. There's mountains of OpenAPI documents. And there's new services coming all the time. And so this environment is very difficult to work in. There's a lot of problems, like how do we ensure APIs are consistent? API users really want a consistent experience between services, even though these are often completely different teams that are building these services. Today, this is a human process of ensuring guidelines are followed. There's some linters, but at scale, this becomes problematic. Mentioning guidelines, how do you ensure that the services meet the guidelines? Again, this is a predominantly human-driven process. Linters can help, but the problem with linters is that they're often operating at too low of a level. You can't necessarily teach a linter that, like, if you see this kind of pattern, what you're really looking at is like maybe a paginated endpoint or a long-running operation. It doesn't know that, and so it can't really give you actionable high-level lints. It can look at smaller things. Another concern is how to leverage existing work. We have a bunch of services that are doing, and parts of it are doing the same thing or consume the same sorts of data or produce the same sorts of data. Wouldn't it be great if you didn't have to think about that and you could just go and grab something that someone else had already done and use that in your service in some kind of first-class way? And how to use the same data shapes across many services and protocols and even other scenarios besides. Azure has certainly tons and tons of HTTP REST services, but there's also gRPC services internally. There's AMQP services, MQTT. There's a bunch of different protocols. There's bespoke data transferring over WebSockets kind of protocols. There's tons and tons and tons of ways that these same data shapes get used across Azure. And it would be great if we could have a source of truth for all of those. And spoiler alert, we think API first is the way to do this, specifically API first in a way that makes some of these concerns more first class in the language, a way to maybe apply the learnings that we have from our programming languages to the task of API design. So with that in mind, let's say hi to Cadl. We're open source and on GitHub. Feel free to check out the GitHub repo. That's where you'll find documentation. And if you try it out and you want to report bugs or just say hello, I suppose, you could do that. That is also where the team spends most of their time working. So if you want to see what we're up to, that's definitely a good place to do it. And the second link is the playground. Cadl runs in the browser, among other places. So if you have your laptop and you want to play along with the demo, head to that link, aka.ms/trycadl, and you can play around with various samples. And it has kind of a two-pane view, so you can see what the Cadl is and what the OpenAPI is. So fundamentally, what Cadl is about is making API-first, productive, and even fun. And it does that in a number of different ways. First, Cadl really embraces OpenAPI. We don't really do anything in Cadl without thinking about what the OpenAPI experience is going to be. The OpenAPI ecosystem is vast. There's a lot of very useful tools and code generators and all sorts of things that people are already leveraging today in their code generation pipelines. And so we aim to make sure Cadl can sit in front of those pipelines and not cause any friction there. So our standard library has an emitter for OpenAPI 3. We internally have an emitter for OpenAPI 2 and custom extensions. If you've looked at our Azure specs repo, you see we have a lot of OpenAPI 2 plus some like Microsoft-specific extensions. And one of the nice things about Cadl actually is that you can generate both of these things from the same source of truth. And so we're hoping that Cadl will be the vehicle by which we can start shipping more standard OpenAPI 3 to folks outside so they can generate clients more effectively for our services. One of the things that always comes up when you're talking about a new tool to build services is, okay, but I have to learn it. Is it worth doing that? And what we're seeing with Cadl is because we've designed this language to be super familiar, we've borrowed heavily from languages like TypeScript and C#, that if you're familiar with an object-oriented language in general, you can read Cadl code and pretty much understand what's going on. Writing it is a short hop from there. Depending on what you're doing, if you're just using some libraries, that's probably pretty easy, relatively speaking. If you want to, write a library, that will take more study, but it's on the order of a simple programming language to learn. And we're seeing that people are able to pick it up pretty quickly. One of the things that makes Cadl a lot of fun is its expressiveness. It's really easy to describe large services pretty tersely. We're seeing, like, even if you're operating at the low level of describing HTTP in terms of gets and posts and headers and routes and et cetera, we were looking at 50% or even more reduction in number of bytes in the description. But frequently you're operating at an even higher level than that, where the amount of code that you're writing in Cadl is substantially lower, and I'll show an example of that soon. Cadl is also super extensible. The core language doesn't really have any opinion about protocol. Those are all provided by libraries. And so we have like I mentioned, we have the HTTP and the OpenAPI libraries sort of built into the standard library. But we have gRPC and PR that should hopefully be coming to the standard library soon. And you can write Cadl extensions that will bring Cadl to pretty much any protocol that you might be using, or even any application domain. And so that really makes Cadl able to serve as the source of truth, no matter where your data is living. And one of the really cool aspects of this extensibility too is that you can customize it with your own metadata. So like, if your organization has a particular kind of data field that it has to care about because maybe you have to audit where that data field moves, or maybe you need to log that in some system, you can write a Cadl library that will allow the API designer to add some metadata to flag those fields. And because you can emit different service specifications like OpenAPI, you can emit implementation code, you can implement documentation, you can implement or emit pretty much anything from this. It really makes Cadl able to plug into pretty much any code gen pipeline. Cadl is super toolable. Of course, it's coming from dev. It's built on standard language service protocol. We have extensions for Visual Studio and Visual Studio Code. You get things like go to definition, you get member completion, you get refactorings, symbol explorer. You can do custom lint rules, which put the red squiggles or the orange squiggles, or maybe they're yellow, in the editor. If you're used to a certain feature in a particular programming language, chances are we have it, or it's coming soon. This tooling is really key to the productivity when you're using Cadl. And I've saved what I think is the most compelling reason that Cadl is awesome to the last. And this is that Cadl is composable. By that I mean you can take an API pattern, like say an API pattern for pagination or for long-running operations, or even like a larger one, like the entire resource lifecycle for a particular resource. Like you have a widget and you want to do CRUD and list operations on a widget. You can take that pattern, package it up into a library, and share that pattern across your service, reusing it repeatedly so you don't have to restate it. You can share it across your organization. So all of a sudden, what used to be a linting problem and a human review problem is now someone makes a library and just make sure you're using that library problem, which is much easier. And you can even share it across the ecosystem. So the ecosystem can start experimenting with patterns, seeing which patterns work and which don't, and over time arriving at more consistent patterns across the entire ecosystem. And it's really, really hard to overstate how much of an accelerator this is of API development when you can cobble together services from these reusable building blocks. What used to be a very low-level task of defining a whole bunch of routes can be as simple as defining your resource type and generating all of the REST routes that fall out from there. So next, I want to go over the basics of the Cadl program. So if you go to the playground, you can kind of see a little bit what's going on there. Now, the first thing that we're doing on line 1 is we're importing a library. And in this case, because it's in the Cadl lang scope, this is our standard library. But again, this isn't privileged in any way. You could write a library and import it here and do similar things. Next, we have a namespace declaration. This is saying everything inside of this file is in this demo service namespace. And we put a decorator on it to say what the title of the service is. And you can see that that is being reflected in the output. Decorators, incidentally, form one of the core pieces of Cadl's extensibility model. So you'll be seeing those quite a bit. Next, we have a using. This is just pulling in some bindings from this namespace, so we don't need to dot into them all the time. Incidentally, if you've used C#, this namespace design should feel fairly familiar. On line 7, we have a model declaration. This is the core of Cadl's schema definition language. So here we have two properties, an ID and weight. We've added this key decorator on ID, which helps the REST library know that this might show up as a path parameter. You could imagine keying off of that if you're generating a SQL table for this or something as well. So if I want to, I could potentially add a field here. So if we say like maybe color, and we can say this is either red or blue. And we scroll down, we see we have the schema here for widget that has the color property that is an enum of red or blue. But maybe I want an actual enum, so you could do that as well. So you could come in and say, hey, we're going to do color, and this is red or blue. And then we can update widget to use that instead. So we get the same thing, except in this case, we're referring to color, which is now an enum since we've declared it. There's other declaration forms as well, like unions, that you'll see if you go to the playground. Next, we declare an error model, and we put error on it. This is, again, just some metadata to tell the machinery that for OpenAPI that, hey, this should be the default response. And next we have an interface. So on line 24, we're declaring our service surface area. The interface generally holds operations and groups them based on functional area. And we put the widgets route on it, so any of the operations in our OpenAPI should be under the widgets path. And inside we declare some operations, list, read, create. Things to note here is we've declared a path parameter for read, and so if we look at that, we get a separate path for that. It gets appended to the path. And we've also have a post body for widget, or for create, and that shows up here as well. So those are kind of the most common features that you'll see in a Cadl program. Now, I mentioned that composition is sort of key to how Cadl accelerates API development. And I wanted to show real quick what that actually means. And so this is pretty much the same thing, just with a bunch more REST operations. But because we've said instead of implementing all of this ourselves, we said this interface extends resource.resource operations of widget and error. This comes from our standard library on the Cadl.rest namespace. We have created an entire REST API for the widget resource, full CRUD operations. And the way that we've done it is really sort of simple, basic, probably okay if you're doing a simple service, but we know that everyone has their own way of doing resources, like whether you support conditional requests, whether you use JSON patch or JSON merge patch for updates, what the verb of that update thing is, there's some disagreement on sometimes. And indeed, inside of Azure, we have a bunch of different opinions, I guess, on how resources look ultimately. And so what you can do is you can build your own one of these things, like this resource.resource operations comes from our standard library. You can write your own. And so your users will only just need to provide widget and error, the resource type and the error type, and you can pave an entire REST API based on however you prefer to do it. There's a lot of other ways to do composition, since this, again, is pretty key to how Cadl works. So for example, you can say model extends. This is a way of doing inheritance. So if we look at the OpenAPI, this will give us an olive relationship. But if you didn't want that olive, you can use spread, which is a way of just inside of Cadl combining different shapes together. It's often convenient just to be able to calculate some shape inside of Cadl that you don't actually intend to be part of your API. It's just a convenience to pull it apart. That can let you assemble models from pieces without complicating the object model of your API. So if we look at my widget 2, we can see, indeed, we have these flattened ID and weight properties in there. The previous example showed operation templates. Models can be templated as well. A template is it takes a parameter that is a type. So when you're using, in this case, a widget envelope, which just stuffs a widget in an envelope, you can pass it, in this case, mywidget2, to say, like, I'm putting a mywidget2 in the envelope. So if you look at the type of custom tprop, we have a reference to mywidget2. If I wanted to change this to just like the base widget, I could do that. And so now, we've got another schema, in this case, to widget. If I try to change it to int32, we get an error because, well, it's kind of cut off because, oh, there we go. It's not assignable because in the template, we allow you to specify constraints. So this will ensure that users only pass in types that you expect. And in int32, it's not assignable, or is not a subtype of widget. So you get an error in that case. So I want to do a quick demo just to show that we can, no, I'll do that later. Just to show that the output of Cadl is really standard OpenAPI. So we have here a simple service. It's pretty much the same as the other examples. I've just added a few things that I know Spectral is gonna want. So the first thing that we do is we're gonna compile this Cadl to OpenAPI. And so we're just calling the compiler and we pass the output format that we want. And next I'm gonna run Spectral and I'm gonna also run redoc because I really like the style of documentation that they have. Here you can see the symbol explorer, which I think is super handy. Okay, so Spectral is run. It's told us that we have, oh yeah, we probably should put the contact field on the namespace. There's a decorator for that. And our docs have run too, so we can open those and see that we have very nicely rendered docs from our Cadl, thanks to OpenAPI. Okay, so that's pretty much all I wanted to show. Again, note that Cadl is a work in progress, and we're really looking forward to hearing what folks in the community have to say and how you want to use it, and you know what feedback you have. So definitely try it out. Please give us feedback. Again, the playground, great place to try Cadl. You can save code snippets and stuff, so it's really easy just to you know, send bits of Cadl around with your team. Again, here's the GitHub, Microsoft/Cadl. Issues and documentation is there. And a big thank you for coming. It's been an honor to talk to all of you. We have to get a new name for Cadl at some point, and so there's a survey here if you're interested in naming. You know, probably as API architects, naming is our day job, but if you want more naming, check out the aka.ms/cadl/rename link. There's a short survey. It would help us out a ton if you could fill that out. And other than that, thank you, and happy to answer any questions. Yeah. Mm-hmm. Yeah, so I think that choice was really just simplicity. It's really easy just to put the error decorator on it and get the behavior. And we see that pattern getting used with some frequency. If you want to use ranges, you can. And you can be explicit about status code for each of those responses. So if we go to if we bring up the code editor here, you could add a status code to this model, and it would, you know, be specifically for that status code. So you can customize the error experience of your API. This is just the kind of simplest, most defaulty thing. But if you have feedback on like if that's like actually bad to do, we would love to hear it. You know, definitely file a bug on that. We want this to be, you know, kind of err on the pedantic side, I would say. Yeah. Yeah, definitely true. I think we tend to use default only for error cases, but I can see how that would not generally be the case. For sure. Yeah, so the question was, can you use the Cadl stuff for more than OpenAPI? And definitely. There's, in the service specification world, like we have gRPC and PR. We are generating, in some cases, clients and servers directly from Cadl. There's a demo on my GitHub showing how, because Cadl is like super extensible, you can use it to describe entire cloud applications. So like looking at this interface on line 37, you can put like @Azure function on there, and then we'll generate you a whole Azure function implementation of those endpoints. And because we even know the parameters in there, we can do the marshalling of those parameters for you. So yeah, there's tons of things that you can generate from Cadl.
So usually generating, like, it's useful to have like other extensions sometimes.
Mm-hmm. Mm-hmm.
I'm kind of curious, like, will I be able to write like a generator that can like add like compiler errors if you're missing those things?
Yep.
Where do those
Yeah.
classes of errors get represented here?
Yeah, that's a huge thing. Like, we really depend on that capability inside of Azure, where we have, we care very deeply about client quality. And while a client generated strictly from the REST API description is often good, bridging that gap from good to great takes a lot of careful design effort. And so what we're actually doing is, rather than what we're doing today, where we go in and we sort of write code in all of the different languages we support, instead we're doing what you said. We're adding metadata to the API description that tells our client code generator how to do a better job in this case, because you as API designer know what the intention of that endpoint is. So we have a bunch of different metadata that some of our client code generators understand to control, like, maybe the name on the wire is widget, but really it should be called something else, or group these endpoints together into one client, and these other endpoints go into a different client, and have them as separate exports from the package, stuff like that. I'd say that is one of the key capabilities of Cadl's extensibility model, is to add metadata to service specs and consume that in an emitter. And in fact, you can do it in a way that doesn't require coordination with whoever authored the spec. So for example, a service team will create a service spec. They don't know anything about your metadata that you might want, because you're gonna consume that, and then you're gonna generate some stuff based on that. So what you can do is create what we're calling a sidecar file, and reference that spec that the service team provided, and add metadata to it that your code generator understands. And then run your code generator, and so you'll emit the sort of merged view of your metadata plus the original service specification. Yeah.
So big fan of Cadl, been using it, playing around with it. I did have a question on, we heard about how Kyoto is having issues with sort of OpenAPI being able to model, type system. And like, I look at this and I'm like, well, you could just write an emitter for SDKs, right, and skip the OpenAPI part altogether.
Mm-hmm.
So that's a whole other conversation, just something to think about. My question is really extension and extensibility. Last I looked, extensions were TypeScript only, but I thought there was talk about being able to model extensions using Cadl itself.
Yep.
Can you talk about that?
Yeah, definitely. So for context, the extension model is, right now, Cadl is implemented in TypeScript, so it runs in JavaScript. And you can, in fact, import a JavaScript file directly into your Cadl program, and that lights up any exported functions in that JavaScript file as decorators. So that's kind of how the extensibility model works right now, is you implement decorators and emitters in TypeScript or JavaScript, and import them into your program. That said, we're working on a couple of things along that front, because we realize, generally speaking, like, for example, if you're doing client code gen, probably an expert in C# client code gen doesn't want to go write JavaScript code in order to do that. So first, a lot of decorators, we don't think you even need to write TypeScript. They're just like attaching some metadata to a type. We're working on now a Cadl syntax for that, so you can declare that kind of decorator directly in Cadl, no JavaScript required. Secondly, we do have a pattern where, and some teams are doing this already, where when you want to write an emitter in, say, Python, what you can do is you can write a very simple JavaScript emitter that all it does is serialize what you care about to disk, and then invoke the Python emitter, which will read that from disk. It's kind of annoying, but as a point-in-time thing, it seems to be working for us. Longer term, we have an issue tracking adding a JSON RPC interface so that you can host the compiler, and talk to it over a rich pipe, essentially calling APIs exactly like you would from JavaScript. So that's in the plan. We're also looking at WebAssembly and some other potential options besides to open it up. So yeah, in the future, TypeScript extensions will not be the only option. Yeah. Any other questions? All right, well, feel free to come find me afterwards. Happy to chat about this at length. So yeah, thanks again. It's been great.